refraction of light. Here we're going to show light waves entering a block of diamond here. Now in reality the light waves are far too small to see, but just so we can get a good idea of what's going on, we're going to show the light waves as being much bigger. Now around the block, this space here, is a vacuum, and in a vacuum light travels at 300,000 kilometers per second. Inside the block is diamond. Now diamond slows light down, and when light travels through diamond it only travels at about 120,000 kilometers per second. So let's see what's going to happen when we place shine light through the diamond. Now notice that the wave just travelled straight through the block. It didn't deviate, it didn't change angles, just it hit the block at a 0-degree angle and continued straight through and came out the other side at a 0-degree angle. Watch this time and see what happens as the light wave hits the block at an angle. The light wave comes in at this direction. When it hits the block, it's refracted, changes direction, changes angle, and out the other side it's refracted back to its original angle. Although the light is refracted, the angle that the light enters the block at is the same as the angle of the light that exits the block. So why is it doing this? Well, remember that as this wave travels into the block, it slows down. Now the bottom of the wave is the first part to hit the block, so it's the first part to slow down. As soon as this wave hits the block, it slows down. Where the top of the wave up here is still travelling at the original speed, the faster speed. So the top of the wave has time to get ahead of the bottom of the wave. The top of the wave is travelling faster, the bottom of the wave is travelling slower, so the whole wave will tilt in that direction. Now if we change from diamond to water, let's see what happens. Remember, diamond has a very high refractive index, water has a very low refractive index, or refractive index that's closer to 1. So the wave in water doesn't slow down anywhere near as much as it does in diamond. So here we have a block of water. As the wave travels into the water, it refracts, but not as much as it did with the diamond. This time we're going to see what happens when the light enters a circular block of diamond. Firstly, the light ray that hit the circle directly on went straight through without being refracted. But if we trace the wave as it hits the edge of the circle, hits the circle at an angle, refracts, comes out the other end, refracts again. and down here, ray comes through, it's refracted, and is refracted out again. Now, these light rays here appear to be coming from some point inside the circle. They're not, they're actually coming from some object far, far away back here. But to a person viewing it from the other side, these light rays appear to be coming from about this point here. This point is called the focal point, or the focus. And if we were to view an object as through say a sphere of diamond, this is where the object would appear to be. It wouldn't appear that the object was behind the circle, it would appear that the object was inside the circle.